Hello, in this video we're going to look at the average rate of change over an interval for a continuous function, and we're going to look at marginal revenue, cost, and profit. Given the function below, find its average rate of change over the interval from -5 to 1 and compare the instantaneous rates of change at the endpoints of the interval. For average rate of change, you substitute the function value of each endpoint value, -5 and 1, into the function. Using your calculator, and be very careful with the location of your parentheses, you should get 21. Calculating the function value at the other end of the interval, using your calculator, should get -15. Okay, to find the average rate of change, over the interval, you will take your function values. For this problem, it's -15 minus 21 over the difference in your x values, or the interval length. 1 minus -5 gives us 6. If you look at the interval in the original problem, to get from -5 to 1, there's a distance of 6 that has to be traveled. So that's all your denominator is the length of the interval. The numerator is -36. This function fluctuates. It's not a line, so it's actually shaped like a hill if you were to graph the original function, but its average rate of change on that interval is -6. Instantaneous rates of change are the derivative values. So we're going to calculate the derivative and then plug in the -5 and 1. Our derivative, and I'm going to do this in a different colored ink, f prime of x is equal to -2x minus 10. Substituting -5 and 1 into this function, the derivative, calculate 10 minus 10, that's 0. The instantaneous rate of change at the other interval endpoint, which was 1, is -12. Average rate of change is just simply that, the overall behavior between two x values. But if you want to know the rate of change at exactly one x value, that's where your derivative comes in. In this class, repeatedly, you're going to see marginal. Now, it could apply to cost, revenue, profit, etc. But the moment you see marginal, start thinking derivative. I'm going to introduce you to a new derivative. You can call this C prime. There's another notation. It's the change in C with respect to the variable in the equation. So that's the change in cost with respect to X, in business terms called marginal cost. It's basically your first derivative. So if you take the derivative of your cost function, you're just going to get 9,300. These are in dollars per unit. Same thing applies with the marginal revenue. You can either call that R prime, or, as sometimes, again, WebAssign will change the notation on you kind of out of the blue. Those mean the same thing. Taking our derivative, we get 32 minus 2x. And again, that's dollars per unit. And then finally, our last example, marginal profit. Again, marginal derivative. The change in profit, which can also be written change in profit with respect to x. Negative 0.35x squared, its derivative is negative 0.70. Take one off your power. Plus 3,000x is 3,000 dollars per unit. Hope this helps.